Hello, everybody, and welcome to today's presentation. I am Professor Avishai Wool, AlgoSec CTO and co-founder. Today, I'm going to be talking about unbeatable cloud security, your path to zero trust and micro-segmentation. So here's the agenda that I prepared for us today. We're going to start with a motivating example of ransomware attacks and lateral movement in them. Then we'll talk about visibility. We'll talk about applications and the combination of those 2 points. And then we'll summarize and give you a chance to ask some questions. So a motivating example of ransomware attacks and lateral movement. So how does ransomware work? I assume you know this, but let's say it one more time. The attack starts with a victim computer that gets exploited somehow. Once that victim computer is exploited, it goes into a cycle where it looks for additional computers to infect over the network. And when it finds one, it delivers the exploit to that new computer. And this cycle repeats and repeats until enough computers have been infected and interesting and valuable resources have been reached. And then the attacker activates the ransomware, encrypts the local files, and the network and all the network file shares. These days, they also steal information to extort the victims. And then they wait for the victim to call. And if the attack is successful for the attackers, then they collect the ransomware, supply the decryption key, and move on to the next victim. So that's how it works. The point I'm trying to make today is that the networks are really crucial here for the attacker to succeed. So if we look at how the attack looks over the network, let's look at it in this little diagram. So we can see that the first computer is usually infected because of a human mistake. Somebody clicked on a link they shouldn't. They opened an attachment that was delivered to them. Maybe they're working from home, outside of the corporate environment. So as defenders, we have not too much to do regarding the first infection because social engineering is very powerful and people just make mistakes. So let's see what happens after that. Well, the next step is that the first infected computer starts to navigate over the network and try to find additional computers to infect. Now, that happens over networks that we potentially control. And maybe our employee working from home jumps to a clock application. They need to log their time. Maybe from there, the attacker would jump to a procurement system. And maybe from there, they'll jump to a financial database. And if they can do all of that, maybe they'll either encrypt the database or exfiltrate the data out and steal it. And the thing to notice is all these arrows, the red arrows, step 1, 2, 3, 4, all of those go over the networks that we as defenders control. So the point of zero trust is saying, okay, we should not trust blindly any of these resources. We should not trust the person that started this attack. We should not trust any of the computers along the way. And so we need to control the traffic, both north-south traffic and east-west traffic. And I've kind of labeled these types of traffic in this diagram. So you can see that the first connection from the work-from-home environment to the first corporate environment, well, that's borderline. Is that north-south or east-west? Let's assume it's over a VPN. There's a fair amount of east-west traffic going between the different zones. And finally, there's again north-south traffic when exfiltration happens. Okay, so this is what we want. So how do we do this? It's not terribly easy, is it? So let's think for a second about where all these networks are. They're in all kinds of different places. And here's a typical setup where, let's say the clock application is in a local data center, but the procurement environment is up in the AWS cloud, and the financial database is in the Microsoft Azure cloud. So we have a collection of different networking environments here, which adds to the complexity. We need to worry about all of these. And this is where visibility comes in. It's key to defending any kind of valuable asset. And not to state the obvious, but you can't protect what is invisible. You can't combat a threat that you can't see or understand. So visibility is crucial. And the challenge that I want to pose here is that when you have a hybrid environment with multiple clouds and so forth, the environment is becoming a challenge. It's not homogeneous. You have all kinds of different things. And let me show you what I mean by that. In the old days, you had a traditional data center. It was on-premise. It was in one place. You knew where it was. You understood it reasonably well. Then you started adding virtualization technologies to that. So now you have a virtualized data center. It's still in the data center, but different technologies are involved. But then you involve public clouds, and there are quite a few of them. The biggest ones are AWS, Google, and Microsoft. With all of these different networks and different environments, you have different technologies. You have different filtering technologies where you want to deploy your zero trust controls. So in the public cloud, you have your native controls like security groups and cloud vendor firewalls from these vendors. But you also have SASE solutions like Zscaler and Palo Alto Prisma and their competitors. You can deploy third-party firewalls in your AWS, Azure, or Google environments. You can deploy Palo Alto or Checkpoint or Cisco or Fortinet. And then in the data center, you have your traditional filtering technologies that you've had for years from various suppliers of filtering technologies for the traditional and for the virtualized environment. So there's lots of technologies, and you have to control all of them so that you can deploy the policies for zero trust. Now, the next thing is what you want. What is it that you're visualizing? What do you want to see? So you want to see networking risks. So, answer questions like, are all my filtering technologies enforcing industry best practices and my organization's zero trust segmentation guidelines? You also want to check whether you're in compliance with whatever regulations you're subject to. You also want to be able to simulate and check whether hypothetical traffic can get from point A to point B, taking into account the routing and the filtering and the English translation and whatever else you have going on. So those are kinds of things that you need to visualize. And with all the technologies that we talked about, this is becoming challenging because you have all kinds of different cross-environment traffic flows to worry about. You have your old school connectivity from your on-premise environments out to the internet or inside the data center, but also you have traffic from the traditional data center to your cloud environments. Then you have traffic inside the cloud environment. Then you have traffic going from one cloud to another cloud. And you have traffic going out from any of these clouds out to the public internet. So all of these types of traffic directions are flows that you need to worry about and control so that you can enforce the policies that you need. Okay, so that's the technology challenge that you have to worry about. Now let's switch gears and talk about another kind of challenge, which is understanding what it is that you see. What is the intent of the traffic that is going through your networks? Because after all, when you want to set policy, you need to know what this policy is applied to. If we talk about applications and we go back to statements from Gartner, we see that it's well accepted that really the application owners should own the risk to their application. It's not the IT or networking teams, it's application owners that really should own the risk because it's the application's data that's sensitive or regulated or whatever it is. The application is critical or non-critical. The application is in one time zone or another. The application has change control windows that apply to it. It's all about the application. And when you're trying to prioritize remediation, you decided that you have a problem, you want to fix something, you have two risks to contend with. You have the risk of not fixing it, but you also have the risk of downtime. If your fix requires downtime, that's a challenge. Sometimes fixes go wrong, you need even more downtime. So you have to worry about these things, and the only individuals that can make prioritization correctly are really the application owner. They see both sides of it. So you need to know who those people are and what they want to do. And this is, again, what Gartner's been saying for a while. The way to do this well is to have a business application repository or portal where you record that you have these applications, what networking flows they rely on, and then all the metadata, contact person information, status, change history, risk and vulnerability information, and so on and so forth. You need that kind of thing. It really, really helps manage your environment. Again, we have a challenge with applications because most organizations that I've spoken to has thousands of applications. And each of these applications has its own servers and clients and communication flows and business units associated with them, and so on and so forth. And these applications are very often not very, very well documented. Most organizations that I've spoken to don't really have excellent machine-readable records of all the application flows running through their data centers and their cloud environments. So maybe you belong to a different type of organization, and for you, everything is documented. And if that's true, good for you. You're in a minority. The rest of us need to discover their applications and understand what's going on because we don't have such wonderful record keeping. So that's another type of challenge. How do you discover these applications? How do you assign intent to the flows that go through the network so that you can apply your zero trust policy to those connectivity flows? So here the answer is diverse. There are many ways that one could identify applications, and it really depends on what information you have available to you, what kind of data you have lying around. And this could come from dedicated micro-segmentation solutions that gather this information. It could come from ITSM ticketing systems where every ticket has information about it. You could use a CMDB, export data from there. You could even go to your traditional firewall policies and try to reverse engineer the applications from the rules. You can also, if you have a cloud environments have very rich information that's accessible via APIs. And so one could imagine spidering out from each workload in the cloud, identifying VMs, subnets, permissions, resources, logs, cloud trails, and try to build a picture of what applications look like using these resources. You could even look at network traffic and try to make sense of net flow or S flow. All of these data sources are potential starting points for an application discovery, but you still need a solution that makes sense of all of this and is able to gather that and give you a picture of what you actually have to deal with. With most of these data sources that I've described, maybe you can identify the actual flows. You can figure out that there's connectivity from here to there, and that these different flows are related to each other, so they belong to the same application, but you still have a challenge figuring out what the application is, or specifically, what's it called? You could, of course, go and ask around, but that's very slow, and you need the cooperation of your peers to look at things and tell you what they're looking at. It's challenging. But here we have a new thing. We're in 2025. We have generative AI at our fingertips. And generative AI is actually quite capable in helping us give names to the identified applications, because most of the data sources that I showed you before have useful text in them. There's ticket descriptions, comment fields, resource names, all kinds of things have names and descriptions and text around them. And our Gen AI suppliers are very good at taking this kind of data, unstructured textual data, and summarizing it to something that's short and descriptive. And these tools are pretty successful in making the right determination and giving the correct name to an application, so that once you have the technical data, what connects to what, and you give it a label, now you can go ask your colleagues, well, this identified an application that looks like it's yours and it's called, I don't know, Procurement 101. What do you think? Does this make sense to you? And all they need to do is say, yes, you're right, or you're missing something, but in general, it's pretty accurate. And, we at AlgoSec have tried this, and it's working really well for us. We'll be happy to share with you details if you want. So this is an effective technology, an effective way of doing things. And this could also be augmented by using a concept that cloud vendors give us, which is tags. All the cloud vendors provide a capability to tag things, tag assets. And these assets could be very diverse. Lots of things can be tagged, for instances, VMs, containers, storage buckets, filtering rules, all kinds of things you can tag them with whatever you want. Typically, it's like a key value thing. So you can say application name equals foreign exchange trading, or operating system equals Microsoft Windows 11. You can use whatever tags you like. GCP has a slightly different way. They just have the key. They don't have the value. So you just tag it with, the name of it is there. But you can tag things any way you like. You decide on your structure, your strategy, how you do this, then go ahead and tag. And the advantage of doing tags is it can help you track the applications. You can tag resources with the name of the application they support. And then you can organize your cloud environment using that. It's very effective, costs you nothing. So I really recommend trying to do this if you're working in a cloud environment. Just start using tags. They're really good for you. And with this, let me just summarize what we've seen. So we saw that zero trust principles are really important. It helps you avoid and control nasty things like ransomware. That visibility, to enable to do any kind of zero trust, you need visibility. And this is a challenge in a hybrid environment because of the different technologies deployed. Using an application-driven approach really helps you identify the intent of various things and helps you write policies in an intelligent way that does not disrupt business. And I recommend using both cloud technologies and AI to your advantage to recognize what your applications are doing and what their flows are and so on. And with that, let me thank you for attending. If you need more information from us, feel free to reach out. I'm Avishai Wool. Thank you for your attention.